All right. Good morning, everybody. Welcome to Introduction to Apex Testing. How many of you went to U2 last night? Hands up. You are my people. You are the ones who stayed up last night partying and still came up this morning to talk about testing, which I know is my favorite topic, so I'd get up this time of the day to talk about testing any day.
Yeah, and this might not be as exciting as the concert was, so I just want to temper your expectations. Oh,
maybe.
Were you going to perform?
I'm thinking about it.
OK, well, stay tuned.
All right, so let's do a little bit of introductions. Hey, I'm Laura Meerkatz. I'm a developer for Salesforce.org. That .org piece may be a little bit unfamiliar, but it basically means that in my job, we get to use Salesforce technology, people, and resources to work with nonprofits and higher eds to change the world. It's awesome. So specifically for me, I get to work with our volunteering tools and build apps that help employee volunteering and grants management. Adam.
And, I'm Adam Lincoln. We are colleagues, and I get to work on our code that runs our community and our donation program. So it's really exciting. It's really fun. We love doing it.
Yeah, awesome. So before we dive in, we're now on day 3. You've probably seen this a bit.
Yes, you all know this. I will just say, don't make purchasing decisions based on things that aren't already available.
Great.
There you go.
OK, so here's what we're going to talk about today. First, we want to know, why do we write tests? Why is this important? It's not about code coverage. We'll say that again later, several times. We're talking about what to test, some best practices. And at the end, we're going to give you some resources. And if you have to duck out early, please check the chatter feed, because there is a ton in the link that we're going to give you there that will give you kind of a recap of what we've done and some additional resources. And then we'll give you a chance to ask questions. So as we dive in, poll exclamation point. Who here is an Apex developer? Cool. So most of our audience. Great. That's mainly who we're here for. Who here has written Apex tests? Good.
The same set of hands.
Yeah, same set of hands. Great. Who here feels like they write good tests? Oh, fewer hands. OK. It's probably OK, because I was totally going to call out anyone who says they're writing good tests and say, all right, after the session, everyone swarm that guy. So before we dig into what you should test, how to go about that, why do we test? Adam, why do you test?
Well, I may have written some buggy software in the past, and it helps me to keep a list in this little notebook here. Every time I make a mistake, I write in this. And so the first one is, so I know that my fixes or new features won't break the stuff that's already there.
That's a really good point. You know, I like to test so that I know that my features work in the first place. When I'm developing new features, sometimes just by even saying what I should be testing, I realize, oh, I didn't actually write that part of the code.
Yeah. Let's see, here's another one. You can use it to know when you're done with your feature.
Yes,
you don't keep thinking. I have this problem where I write something and I think it could be better, and sometimes you just have to button it up, be done with it, and writing tests beforehand is one way to do that. So
yep.
I'll fold this up while.
And mostly, I write tests because I like to sleep at night. That's it. I want to know that when I put new code into production, it's going to work. I'm not going to get calls at 2 a.m. And we're not going to have to sit here and click through everything and pretend like that's enough to tell us whether or not something is working. Yeah.
So it's great to write them, for sure.
So we didn't say the one thing that everyone says about test coverage in Salesforce. You do technically need 75% coverage of your code to get it into production. And that's technically important. But you can really write coverage without ever writing a real test. So I don't like to think about my tests that way. I like to think about my tests for what they can really tell me and what they can do for me.
And at the very end, we will talk a little bit about how you can use coverage as a tool to understand what you are flexing in your code and how you can improve your code suite, or your test suite.
Great point. So just for anyone who hasn't really written a test before, we're going to go over this really quickly. Let's talk about some basics. Here's our structure. Here's what a test looks like. You're going to be in a private test class, which will have that is_test annotation. You will potentially have a test setup method that's going to help you set up some test data that all of your methods will use. And then the body of the test is really just a static void method with some good name that will help you understand what it is you're testing, and that is test annotation. We'll get into the details a little bit more, but that's kind of the basic structure. But here's the important part. When you're sitting down to write tests, like, what are you actually looking for? What are you testing? So these are kind of my big 5. And essentially, like, the first 2 are really intuitive, but good to think about. You want to test for things that should happen. Call those positive tests. You want to test that things that shouldn't happen don't happen. So those are negative tests. You also want to test for some special things like user access. So users who shouldn't have permission to do a certain thing can't do that thing, or users who should have permission to do a certain thing can do that thing. You want to know that if you have any exceptions in your code, that they're handled correctly. So if you're expecting those exceptions, that you're testing for those. And then you want to do bulk testing. So let's look at the details. Here's a sample scenario of some code that we may have written where we're awarding employees a 1% bonus based on the amount of their closed won opportunities based on their ownership. And the maximum bonus is $25,000. We don't ever want to go over that. Only admins can retotal bonuses, and a negative total opportunity amount is totally weird and should never happen, so that's going to throw an exception. So without even looking at our code, like, let's think about some of the things that we would want to test.
I love the scenario. It's the old standby.
Yeah. So the things that should happen, you should get a bonus if you have closed won ops. Things that shouldn't happen, if you don't have closed won ops, you shouldn't get a bonus. You shouldn't get a bonus on opportunities that are still prospecting. You should not be able to get a $50,000 bonus. Access testing. If you are a basic user, we've just said admins only can do this, so no one else should have access to that. And then the obvious, like the last one kind of writes itself. If you have a negative total opportunity amount, then you should throw an exception. So what does that look like? Here's our positive test, our first one. And we're making sure that we are awarding our bonus. This is a little bit small, so like I said, we are, at the end of this session, we're going to give you a link that has a GitHub repo with all of these examples in it if you want to spend some more time with it there. So the first thing that we're going to do in any test is set up our test data. So in this scenario, we are awarding a bonus. You know that because I put some good comments in here to tell myself what I'm doing, and because I put a nice short name on this method that says, basically, this is what we're doing. So first, we're going to set up our test user. We're going to create some of those closed opportunities. We're going to create one that isn't closed so that we know that that amount shouldn't be included. We're going to execute the logic. We're going to query for our updated record. And then we're going to do an assertion at the bottom. And that bottom piece is really the most important part of your test. Tests without assertions aren't tests because they can't possibly fail. So that last statement, system assert equals, is saying that first value, 1,010, is our expected value. That second value, employee.bonus, is our calculated value that we're comparing against. And that third parameter there is a message that will show up for me in the developer console so that I can get a nice message that says, hey, here's exactly what went wrong. That part's optional, but I found that to be really useful in my testing.
It will make your future self very happy with your past self.
I mean, all of this is really about making your future self happy. And here's another example of that. And I'm showing you another example because it's basically just the same pattern, right? You start with setting up your test data. Next, you're going to execute the logic that you're trying to test. You're going to query for that updated record to make sure that you're actually getting the current information. And you're going to assert your expected results. Pretty basic, same thing over and over again. So here's that negative test. Here's the thing that shouldn't happen doesn't happen. And it looks a lot like the positive test, except in this case, we're just not awarding it. There are no opportunities, so we know that this user shouldn't get a bonus. And when we get to that assertion, we're doing an assert equals null. So we know that that employee bonus should never have been calculated. And here's another one, same thing, using some open opportunities. And since this actually looks pretty similar, I'm going to move on pretty quickly. Believe me, if you don't get a chance to read through all of this, it's about the same. So here's where things start to really get interesting. You want to not only test that your code works kind of generically well, but you also want to know that it works differently for different users in cases where it should. So that's where system.runAs comes in. So if you look, the pattern that we're using here is basically setting up a try-catch block. We're setting up a Boolean flag that tracks whether or not an exception was ever thrown. anytime you've got kind of conditional branching logic in your code, that you want to make sure you're actually hitting that branch. So if we don't have that Boolean, we don't even know whether the assertion inside that catch was ever caught. And so we're using system.runAs. We're setting that as a standard user who is a less privileged type of user. We are trying to execute our code as that user. And then we're saying an exception should have been thrown. That user should not be able to do the thing that we're talking about here. And this is another slide that's specifically about exception testing, but it's going to be the same sort of thing. So you're checking to see that an exception was thrown. And then within that catch block, you can do some specific checking to see that not only was an exception thrown, but it was the specific kind of exception we were expecting. So we're doing a system.assert that our exception is an instance of that particular kind of bonus exception that we're expecting. Last but not least, and this is an easy one to forget about. You can kind of get away with not doing this a lot and then realize once you get into production that sometimes your users want to operate on more than one record at a time, especially your admins. And if your code only works on one record at a time, it doesn't really work. So we use bulk testing to go ahead and check that when we're working on large sets of data, that it's still going to keep running the same way. And in this case, I'm doing this, if you look on line 94 there, I've got a method for in my test data setup, and Adam's going to talk more about that, kind of managing your test data soon. But I'm basically creating 200 records to work on there, and then we're operating on those 200 records in a batch, and that's the batch size you need to work with because that's going to be how Apex is going to chunk things out. So 200 records, you're good to go.
And Laura already mentioned that this is easy to overlook, in particular if you're relying on code coverage to tell you what you haven't done in your code. You will overlook this.
Great point.
Making this test plan ahead of time can be really helpful.
Awesome. All right, Adam, why don't you take it away and talk about test data?
Sure. So setting up test data is a challenge no matter what platform or what language you're working in. So we want to spend a little bit of time talking about strategies for making this as easy as possible in Apex testing. So first, there's this very strong red warning here. This scenario happens, in my experience, primarily when someone is taking over an org, or when someone is, if there's a group working together where there might be somebody playing an admin role and somebody playing a developer role, and the developer role goes away maybe because it was a partner or somebody helping out, that role goes away, and the admin is in charge of maintaining this code. If some of those tests are on the older side, or they were written using older patterns, this might be there. So I just want to mention this for folks who are sort of getting into this. CL data equals true is avoid whenever you can. There are a few reasons. Number one, and let me just tell you what it does. If this is absent in a recently written test, then the data that your test sees is only the data that's created for the test. It can't see the data in your org, the real production data, unless you add this flag. There are a few exceptions to that. One, for example, the user object is always available. There are other sort of similar admin type objects that are available. But by and large, without this flag, your data is hidden from your test. So that's why test data setup is so important. If you use this flag, you need to look out for things like row lock contention, where your test is operating on something that's really being touched by a user in the active org. You have to worry about how fast your test will run, and you have to worry about the difficulty of grabbing the records back to assert at the end. So that's sort of the requery step that Laura talked about. So just to scare you, get rid of this whenever you can. There are a few places where you may need to use CL data equals true. One that we run into in our everyday job is if you're running Apex tests that talk to the Chatter Connect API out of Apex. You probably need to include that, and then you need to change your strategy a little bit to account for the fact that all of the data in your org might be available to your test. So instead of relying on the data state of your org to run your tests, you'll be setting up a test data. So the examples that Laura showed, call a test data class, if you noticed, a static method or a number of static methods on a test data class. Here's an example of what that might look like. There are a lot of strategies to do this. This is just an instance where you can see we're taking a number in, and we want to make a number of accounts, insert them, and bring them back to the test. So we know that this is a consistent way we're going to make our test data. These are really useful. You can imagine this would be pretty long. You could have create accounts, create contacts, create opportunities, create custom objects, whatever you need. And then if you're working in a team of developers, everybody can use this, and we all have a common understanding.
Yeah, and this is one of those things, I'll just admit that in my first couple of years as an Apex developer, I never did this. And then as soon as I did, I'm like, oh my God, why did I spend so many hours setting up the same data over and over and over again when I could just do it once and kind of be done with it?
Yep. Yeah, pretty useful. This was in the skeleton on one of the first slides, but the test setup annotation tells the testing framework what method it should run when it starts the test for that particular test method. It runs in its own Apex invocation, which means it sort of runs beforehand, all the limits get reset, and then your methods will run using the data that is set up here. Also note that if you have a sequence of tests, when they touch the data that was made in the test setup method, those changes will get rolled back before the next method runs. So you can rely on, at the start of every test method, you can rely on this data looking exactly like it does at the end of this method. There's one little trick. This method doesn't expose, for example, an ID of what it inserted to you. So you have to make sure that you requery the records that you inserted here in your tests. Fair?
Yep. But that is another step that will both kind of consolidate your code writing, and it actually just makes your tests run faster, which is nice.
And you might find, so if you're writing good tests, then you might be trying to determine whether you're running into Apex limits. For example, the number of DML or data manipulation statements that you make, or the number of queries that your real code performs. So if you're testing those limits, then you might find that as you insert test data in your test, the insert statement will sort of eat up those limits. And where you have code that wants to maybe go right up to that limit of DML statements before it hits the Apex governor limit and then stops itself, you won't actually test that functionality because you're eating up 1 or 2 or 10 statements before you get to your real code. So these very handy, and they do so much more than this, but these very handy start test and stop test methods should be part of your tool set. So this is an example. We are using our data factory to grab a user, and then we're using our data factory to create a bunch of opportunities, and then we're changing them a little bit for this particular test. But we've done some DML. We've done an insert. So if we want to make sure that our update employee bonuses bulk functionality works correctly, then we need to make sure those governor limits get reset. So start test will do that. And then the pattern is after you call the method that you're really flexing in your test, follow it up with a stop test call before you do your requeries and assertions. The other thing that stop test does is if your code spawns any asynchronous methods, like future calls, queuables, or batchables, then stop test tells the testing framework to wait for all of those things to actually run before you requery and assert, which is really important because you want to know that all of your otherwise asynchronous code has run, and you want to test the functionality of it. So 2 places whenever you need to reset governor limits and whenever you need to make sure asynchronous code runs before you assert. Start and stop tests are really important.
All right.
So I'm going to hand it off to Laura here. She's going to...
We spent a lot of time in PowerPoint. Let's get out of PowerPoint.
Yeah, right.
Yeah.
Who really wants to do that? Nobody.
So here we're going to hop into our old friend, the dev console. And I will say, even if you're not writing your code in the developer console, that it's a really great place to run tests. And we're going to see why. So to run our tests, you can either open the class that you're testing, or the way that I usually do it is by going under the Test tab and going to New Run. And here you can select which class you want to test. And this is the thing that I really love about this. You can even select which specific methods within that class you want to test. So we're going to do all of those right now. But if you find yourself debugging something and you've got a class that has 50 different test methods in it and only one of them is failing, the ability to only rerun that one test is key.
Thank you, Apex team.
Yeah.
I used to not be
Once
like
we
that.
selected our tests, and we could grab things from multiple test classes here, so we could pull some of these in too if we want to. All we're going to do is hit run. I actually forgot if we made all these tests pass for the demo, so this is the exciting part. And so you can see we got a failure. You can see our results are showing up down here at the panel at the bottom. I can expand this, and I'll zoom in a little bit. And this is going to be organized by our different test classes. If I open this up, I can expand this to see the specific test methods and which ones are passing and failing. And if I see I've got a failure, I can double-click on this failure to pull it up in the panel. Here, this is where we're going to see our errors. We can click into one of these things. And this is where we see where our exception is hitting, or where our assertion is failing. Also some great grammar in there by my part. Oops. So this is where those statements in the third parameter in your assertions are really handy. You can tell yourself exactly what's going on at this line, so you don't have to go back and reread your code and try to make sense of it. You can know exactly what's failing. Cool.
Take over.
You want to talk about coverage?
Sure.
Coverage in the good way.
Yeah. One little thing I'll just mention is these are all sortable, these columns. So a lot of times I'll have a test run that has like 100 test methods, and I don't want to scroll through and see which ones failed. It's just really easy to click this and bring all the failures to the top or the bottom. And these are also reorderable if you want to get a sense of without clicking on each one. So code coverage. Love it or hate it, it's real. So one way to view the code coverage results, and I should say that this is API exposed, so you may be using it, or you may find or be using an IDE that can grab the stuff and bring it locally so it's viewable in a different way. But in the dev console, one way to find code coverage information line by line is to go down here to the bottom right under the overall code coverage section and give the old double click on one of these class names. And you'll see if I can get rid of this. Go away. Go away. That's better, at least. The Apex class or trigger editor opens up. You could write code here if you want. If you don't have an IDE, if you're not interested in using the migration tool, this works great. But when you're displaying code coverage using this little drop-down up here, there I changed it to none. You can do method-specific stuff. Here I'll do all tests. Anything that's this sort of blue-purple color, I'm not great with colors, those are lines of code that have been run in a test. So it doesn't tell you which test. It doesn't necessarily tell you much about the state of their code at the time, but it can at least tell you whether it ran in the test that you've recently executed. For those lines that aren't run, you can see we've done a great job here. Let me pick another one. For those lines of code that were not run, they'll look bright red. So personally, what I like to do is use the dev console to come in here, open up the classes, first review on the bottom right whether what the percentage looks like, just to get a sense of how I've covered it, and then open up a class. And if you see red sort of inside of an if block or an else block, that's an indication that you have another test to write. So as Laura mentioned, sort of the negative tests, it can be really hard to understand where to stop when you're writing negative tests. This is one tool that you can use. If your conditional blocks are blue-purple, then you might be getting to the place where you can stop writing those tests. You've covered it enough. So this can be really useful. Don't just cheat to make the code coverage requirement. Please, the world will thank you in one way or another.
Awesome.
We good?
Yeah, let's go back and do a little summary, and then we'll get to Q&A. OK, so here's everything we talked about today in a nutshell. Tests help you sleep better at night. That's the main reason to write them. It's ultimately going to save you time. It takes a little more work up front, but it's going to save you development time in the long run. Tests, you should test for things that should happen, things that shouldn't happen. If you don't remember anything else, that's a great way to just think about intuitively, what should I be testing? You can use test data factories and test setup to make creating your test data much easier. And again, save yourself a lot of time, make your future self love your past self. And just like Adam just showed you, you can use the developer console to check code coverage. And as I said, you can use it to run either individual tests or as many tests as you want. So with that, thanks for listening. If you would like to ask questions, we've got some mics up in the aisles. Maybe we just covered everything perfectly and no one has any questions after that. This is the URL to our session. Like I said, we have all of our code samples and a few explanations up in our GitHub repo. And we actually have some bonus material in there about testing.
Laura wrote a great piece, so you should go read it.
Thank you. Yeah. Yep, so there's some additional material that we didn't have time to cover today that you can go find there. No one's going to hit us with any hard questions.
Thanks, everyone. Have a great day.